Welcome to the Explainer. We're diving straight in today because we are embarking on a truly mind-bending mission. We are taking a highly technical physics paper by Sabir Al-Rahman, which is this incredibly dense, mathematical exploration of black hole singularities, and we're translating it into an epic cosmic journey. We're going to explore exactly what happens when the very fabric of space-time twists back on itself.
So imagine this for a second. What if we could surgically remove the physics-breaking singularity at the center of a black hole and just replace it with something smooth? For decades, physicists have wrestled with the center of rotating black holes. It's a place where the math just seems to completely give up. But what if the center isn't a dead end at all? What if it's actually a bridge to something else entirely?
Here's the roadmap for our cosmic journey today. First, we'll cover the Kerr's singularity problem, then the gluing obstruction, building the finite core, two universes or one, the rotation classification, and finally, a journey through the core.
Starting off with Section 1. The Kerr singularity problem, and the breakdown of physics.
A rotating, uncharged black hole is described by something known as the Kerr metric. Now, while the Kerr exterior, which is the math describing everything outside the very center, functions beautifully, right at the core, at radius 0, sits this catastrophic ring singularity. It's essentially a ring where the curvature of space-time becomes infinite. The equations literally break down. It's a tear in the fabric of reality that physicists absolutely despise.
Which begs the question, how do we actually fix a broken center? That brings us to Section 2, the gluing obstruction, which is basically a crime against geometry. You might be wondering, well, if the center is the only broken part, why not just take some mathematical scissors, cut out that bad ring, and glue two perfectly good black hole spacetimes together? It sounds like an elegant, easy solution, right? But doing this creates a reflection obstruction. While the basic 3D geometry matches up perfectly, the way that geometry bends in 4D spacetime clashes wildly. The curvatures violently reject each other. In physics terms, the vacuum-Darmois-Israel matching condition completely fails. You literally cannot just tape two black holes together.
So if duct tape doesn't work, what is our mathematical workaround? Section 3. Building the finite core, or the topological bridge.
The core thesis of our source material proposes a pretty radical alternative. Since the zero-thickness glue job fails, the author proposes a finite core. Instead of a sharp, impossible seam, we replace the singularity with a smooth, compact topological bridge that actually has width. It acts as a physical source connecting the geometry without breaking any of the laws of spacetime curvature.
But if we're building a bridge, what exactly is it connecting? Section 4. Two universes or one, the mathematical reality.
On paper, mathematically, we map this out as a time-orientable double cover. Picture one exact Kerr exterior on the left, think of this as our universe. Then you have a second exact Kerr exterior on the right, a second universe. And joining them in the middle is our smooth, finite-width core. In this purely mathematical view, if you fall into the black hole, you traverse the core and pop out into an entirely different, perfectly matched universe.
But here's the wild part. When we translate this math into physical reality, what physicists call quotienting it down, we realize it's not two universes at all. It's just one universe. By crossing the core, you aren't traveling to some alternate dimension. You're traveling through a topological bridge that twists right back into our own universe. It's incredibly similar to a space-time Mobius strip. The bridge connects the universe to itself.
Keeping that twisted topology in your head, let's hit Section 5, the rotation classification and the spinoroid twist.
If you strip away the really dense topology of the paper, it essentially proves a fascinating binary outcome for this finite core. If the core is built from simple mathematical shapes, rotation works exactly like you'd expect. A standard 360-degree turn puts an object right back where it started. But if the core contains more complex primes, we get a spinorial 4-pi rotation. In this bizarre reality, turning an object 360 degrees leaves it in a flipped, non-trivial state. You literally have to rotate it a full 720 degrees just to get back to your starting point.
To actually make this work, the paper uses a specific mathematical shape called the Poincare homology sphere as its preferred benchmark core. Why? Because adding it to the core triggers this bizarre 720-degree rotational reality without ruining the branch conditions of the black hole itself. It is a perfectly smooth mathematical blueprint for a universe where a single rotation simply isn't enough to come full circle.
All right, time for the ultimate payoff. Section 6, Journey Through the Core.
Let's walk through this step by step to see what traversing this core would actually be like. You enter the projective core patch, you cross the theoretical disk transition, and then something completely mind-bending happens. Your inherited time orientation reverses. You actually have to cross the core a second time just to put things back to normal.
Picture this. You're in a spaceship moving across the theoretical boundary of this disk patch. As you cross the transition, your radial position, where you physically are, remains totally unchanged. But your angular order instantly reflects. It's as if the universe you emerge into is a sudden mirror image of the coordinates you just left.
The math here is incredibly specific. Your polar distance from the center is perfectly preserved, but your angle reflects and your transverse normal reverses. The topology seamlessly matches your entry and exit points across this mathematical boundary without destroying you or your ship. There is absolutely no infinite gravity singularity here to crush you.
For you, sitting inside the ship, everything feels totally normal. You glide smoothly forward. The geometric tangent remains continuous. And most importantly, your proper time continues ticking normally forward. Your clock doesn't suddenly stop, and it definitely doesn't run backward inside your cabin. But here is the massive twist, the payoff of that space-time Mobius strip we talked about earlier. While your watch is ticking forward normally, your relationship to the universe outside the core has completely flipped. Your inherited asymptotic future has reversed. To the outside universe, your ship is now moving backward through their time. You are an anti-time traveler. And because of the topology, the only way to snap back into temporal alignment with the outside universe is to literally turn the ship around and cross that finite core a second time.
Which leaves us with a truly provocative question to wrap up this explainer. The mathematics of replacing a black hole singularity with a finite core proves that traversing this topological bridge smoothly flips your temporal relationship to the rest of the universe. So, if these structures actually exist out there in the cosmos, could this mathematical quirk, this literal twisting of space and time, be the theoretical blueprint for time travel? It is a fascinating question to ponder. Thanks so much for exploring the depths of the Kerr core with me.